Hello everyone, this is Dr. Sirisha from Institute of Aeronautical Engineering College. Today we are going to talk about queues. Queue is a linear data structure. What do you mean by linear data structure? A data structure in which data is stored in continuous memory locations. As in our previous sessions we have seen what a stack is, right? Even stack is a linear data structure. Queue is also a linear data structure. Then what is the difference between two? A lot of difference between these two are there. Then what is that? Let's see. A stack, what it tells us about. It always tells us about that you can access the data which is at the top position. Whether it is whatever the element it may be, whether you want to insert or delete, we have access rights to only the topmost element. But it is totally different in case of queues. Queue is a beautiful data structure which follows first in, first out. That means the element which you insert first, which enters the queue first, can be removed first. Right? So that is a queue. Basic definition. Queue is a linear data structure which allows you to delete an element which is been inserted first. First in, first out. FIFO we generally call it. Then what are the operations that we can perform on a queue? First one is enqueue. Enqueuing is nothing but inserting, adding an element into the queue. Right? So where we can add at the rear end. Remember guys, we have two ends in a queue, front end and rear end. For example, a queue is something like this, then front end and rear end. So say if here is your front and here is your rear. So we insert the elements at the rear end, increment the rear, insert the element over here. We remove the elements at the front end. In this position. If you want to remove, increment the front, remove this one. Okay, this is how we delete or dequeue. Perform. I'll show you everything how it works in this queue session, right? So enqueue is insertion or addition, whereas dequeue is removal or deletion. Enqueue, what is the problem that we get in enqueue? Is if the queue is full. Even queue is having a confined space, say n number of elements. Say n number of elements. If n number of elements are there and if you try to insert an n plus 1th element, then it will pose a condition saying that overflow condition. That means which says that you cannot insert any element further. It is overflow going out of the limits. Right? So that is the point which you need to be very careful while working with your enqueue operation. Next one is dequeue. Dequeue is nothing but removing the elements. So removing the elements, very simple. Then what is the problem that you might get into that? When the queue is empty. When the queue is empty, removing an element from an empty bag is of no meaning. Right? So at that time, underflow condition raises. If you try to remove an element from an empty queue, it will raise to a underflow condition. So the next operation is full and is empty. Is full is to check. Is full is to check whether the queue is full or not. So this is the function which you have to use before going for enqueue operation. That means before inserting an element into a queue, just check whether the queue is full or not. If it is full, just say statement saying that the queue is full, we cannot further insert. If not, perform the enqueue operation. Is empty is the next function. Is empty is the next function, which says that check whether the queue is empty or not. This will be useful for dequeue. So rather than encountering the underflow condition, first raise the is empty function. If it returns true, saying that the queue is empty, then just says statement saying that the queue is empty, DQ operation cannot be performed, or else perform the DQ operation. So is full and is empty are the sub-functions which will be used in your NQ and DQ operations respectively. Next one. Next two operations are front and rear. To return the elements present at the front end and rear end of the queue respectively. So these are the 6 basic operations that we have on queues. Then let's see stacks versus queues. As you can see how the elements are placed. Stack at the top is pointing to the element E. So you have access rights only to E. If you want to insert an element, insert above E. If you want to delete, remove E. Only with reference to the element E we are going to talk. You don't have access rights to the remaining elements, and both the operations you have to perform on the top only. A contrary to that is queue. If you want to insert at the rear end. If you want to remove at the front end. Means here, if I want to insert, I'll be inserting something over here at position 5. If I remove, I'm going to remove it. Right? So my operation is not biased or stick to it is not one-sided operation. Okay? This is a different kind of data structure. A style in which data is being stored and operated internally. Okay? So let's see queue operations. So here F, the letter F signifies front and R signifies rear. Okay. So initial values of rear and front are -1, which say that, what does it say? It says that the queue is empty and the maximum size of my queue is 6. 6 values it can take maximum. So initially, I'm trying to NQ 6. So the condition says that, initially what was the condition? My front and rear both are pointing to -1, right? So when I insert 6, an element has entered the queue. So by front and rear, both pointers are pointing to that value 6, right? So now in NQ 15 means I'm going to insert a value 15. Where I have to insert? I have to insert at the rear end. Increment the rear, insert the value. Are you going to change the position of front F? No, not required. At front end, I remove the elements. For DQ operations only, I think of front. Okay? And again, NQ21. In which side we are going to insert? At the rear end. Increment the rear and insert the element. So my rear is pointing to 21 now. Next operation, NQ11. At the rear end, I have to do this one. Increment the rear. Now rear is pointing to index value 3. It is pointing to index value 3. Right? NQ7. Increment the rear value and insert the value 7. Right? So my rear is pointing to index value 4 to the element 7. NQ14. Rear will be incremented, index value 5. Again NQ2. Now the problem rises. I hope you can say that rear is pointing to the last element in my queue. Can you see that? It is pointing. If I try to insert an element now, what will happen? Overflow condition. Or we are trying to insert above its limit. So what is the condition which tells you that you are above? When rear is pointing to n-1, where n is the size, maximum size of your queue. If rear is pointing to n-1, that is the maximum size of queue, and if you try to insert an element further, it gives rise to an overflow condition. Guys, I hope you understood this. Let's look at DQ, removing. What did I tell you? We remove the elements at the front end. So I incremented the pointer F. Actually, my front was pointing to 0. After DQ operation, it is pointing to 1. It is pointing to 15 now. Again DQ, Where it will point now? It will point to index value 2. Very simple. Again a DQ, let's do. It is pointing to index value 3, front. Again a DQ. It is pointing to index value 4, front. Remember, whenever I was performing insertion operation, with that is NQ operation, I was talking about only rear. I was incrementing the rear. I didn't touch different. When I am performing DQ, I am only talking about front. I am not talking about rear. Right? Its position will be as it is, rears. Again DQ, let's do it. Now, check this one. Now my front and rear are both pointing to a single element, which is 14 at index 5. What does that mean? Understand this point. Whenever front and rear points are equal, that tells that and one more condition I can place. I can say that and front and rear both are not equal to -1. What do you mean by this? Front and rear are not equal to -1, but both are pointing to same index value. What do you mean by that? It means that is the last element in your queue. That last element need not be the element at the highest index value. It can be at any intermediate position. For example, in my queue of size 6, if I perform 3 insertions and I perform 2 deletions, very simple, 3 insertions and 2 deletions, then your front and rear both will be pointing to the element at index 2, that is the third element, right? So, which is the only element left over in your queue. So, right, this is the case where you have to think when you perform what? Deletion operation. When you perform a deletion operation. Okay. What will happen if I try to delete now? Both must be sent to -1, which is the primary value. Primary case where, because what did I tell you? When front and rear are pointing to the same index value and both are not equal to -1, that itself tells that the queue is having a single element. Only a single element. So when you remove that element, then it becomes an empty queue. What is the conditions? What are the initial values of front and rear in an empty queue? Both are at -1. Okay, so 14 was the only element in my queue. When I removed it, so my queue is having the initial values as -1 and -1. Okay, what if I try to remove an element now? So both are having values -1 front and rear, that itself tells that the queue is empty. Then the condition underflow condition raises. Then an underflow condition raises. Guys, I hope you understood the NQ, DQ operation, how the front and rear pointers are going to move. What do you mean by underflow condition? What do you mean by overflow condition? Right? So what are the advantages of queues? What are the advantages of queues? A basic advantage is it can hold heterogeneous data. The same with stacks also. Okay, they are flexible, fast, because it's not that you are going to perform everything at one end. Insertion at rear end, removal at the front end. Both the ends are being equally used, right? So that itself is an advantage of a queue. Okay, and you can enhance the length of the queue also. Okay, you can enhance the length of the queue. Disadvantage. This is the basic drawback of a linear queue. Look into that picture once. In that picture, you can see that your front is pointing to an index value 3 and rear is pointing to an index value 5, which means that rear is pointing to the maximum element in your queue, right? Maximum indexed value in your queue, right? So at 5. So what will happen if you try to insert an element? Now, So what was the condition which we learned that if R is equal to n minus 1, that means if R is pointing, rear is pointing to the maximum index value, then overflow. If you try to perform with this condition, it is an overflow condition. Yes, the condition is very much true in this case. But what about this empty space? Is your queue actually empty? No. It is only 50% full and 50% empty. But the condition which we have is if rear is pointing to n minus 1, it is an overflow condition if you try to insert, and it will not allow you to insert even though your queue is not empty. So this itself is the major drawback of linear queues, the queues which we have learned just now. Right? Even though we have empty spaces, we cannot insert the data if your rear is pointing to n minus 1. And this causes starvation. Think wisely. If you want to insert the things, this is the current scenario. How can you start inserting a successful NQ operation? How can we do this? First, remove your level. Your front will be pointing to 7. Remove 7. Your front will be pointing to 14. Front and rear both are pointing to 14. Remove 14 also. In that case, your front will be rear equal to minus 1, which means that it is an empty queue. Now, if you want to insert, yes, it will say that, wow, I can do that. It will start inserting from here. Means what? In this current scenario, if you again want to start an insertion operation, that means if you want to NQ, you have to remove the remaining list. You have to remove the remaining list and then perform your NQ operation. Do you think it is a very good option? It is not even a better option. It is the worst option, I can say. Because what if the remaining filled in data in the queue are valuable data? Unnecessarily, you have to remove it, store it in another place, perform insertion, again reinsert from the stored place the data. It is a highly tedious task. It is a highly headache task, right? So that is the basic drawback of linear queue. Yes, we do have different types of queues which are going to rectify that problem. Those are circular queues and double-ended queues. In the next coming sessions, we will see what a circular queue is and what a double-ended queue is. How they look like, how they are going to overcome the drawbacks of a linear queue. Okay, let's complete our queues, linear queues, understanding linear queues completely. What are the applications of queues? Actually, why we are learning queues? Because we heard that they are the data structures which are used inside the computer, not at theater or somewhere in queue in general, physically. No, right? Internally in the systems, how they are used. Let's see. The first one is resource sharing. When multiple consumers or multiple clients are there, then for resource sharing, we use queues. The one who have asked first will get the service first, like CPU scheduling, disk, memory, anywhere. Okay. Second one is when the data transfer is asynchronous in nature. Means, what do you mean by asynchronous in nature? Source is there. It is sending packets of data to the destination. Source is very fast in nature. It is sending packets by packet very fastly, whereas our destination is very slow in receiving. So what it is going to do, it cannot tell the source to stop, right? So rather than that, it will maintain a queue. It will place the packets in the queue and it starts taking them one after the other in the order they are inserted. Means first inserted one will be taken by the destination first. That means when the speed of the source and destination are not equal, the rate of sending and the rate of receival are not the same, then we call such a transmission is known as asynchronous transmission. In those cases, the destination uses a queue, right, to store the data. Next one is handling of interrupts. Errors. Many errors are going to come while, for example, you are working with your system and an external device being attached. Most of the cases you will be seeing, right? When you insert your pen drive, immediately your system responds, your antivirus responds and says that USB has been inserted. If you insert and that corresponding driver gets executed, right? So for all the interrupts, internally also, for all the interrupts, queues will be used. Queues and that means the first interrupt, I don't mean error, it interrupt. The first interrupt will be entertained first, will be resolved. Interrupt is nothing but some problem it is having, right? Its problem will be resolved. The one who arrives first, that interrupt will be entertained first, right? So in real life scenarios, call centers. So if we are calling to any call center, if that call center person is busy, then you will be placed in a queue. If I'm trying to the same number and you are also trying to the same number and you have called first, even though both have called for our own purposes and that third party, your BPO person is busy, as you have tried first, you will be entertained first and then he is going to lift your call first and then mine. Right? So in real life scenario, anywhere in real life scenario, we see queues in many applications. Right? I hope you understood what a basic queue is, what are its operations, what are its applications, what are its advantages and disadvantages. In the next class, we are going to see what a circular queue is and what a double-ended queue is and how the operations are performed. The same old operations, all the operations which we have seen in a queue, that is NQ, DQ, is full, is empty, front, rear, everything, all the operations that we have seen in a linear queue, we are going to see how they have been applied in circular queues and double-ended queues and how they are going to overcome the disadvantage of linear queues. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.